So what is energy stored in magnetic field? See, the magnetic field is related to inductor. Okay, so the energy stored in magnetic field is nothing but energy stored in inductor. Okay, and what is inductor? We have seen that the device which offers the self-inductance. And what is self-inductance? We have seen it is the property of the coil which opposes the change in current, or which does not allow any sudden change in current. So the property offered by that particular device is called as the inductor, and energy stored in that inductor is called as the energy stored in magnetic field. So now consider a circuit which is having the inductor of the value L Henry, okay, and it is connected in series with the battery and the switch. So consider an inductor connected to a DC source. If the switch is on, the current flowing in the circuit increases gradually from 0 to its maximum value, or say final value. Okay, and the magnetic field is established. When the current increases, or during the rise of current, an EMF is induced across the conductor due to the change in flux linkage. Now, how the current will increase? Here, I have not shown a series resistance which was variable. If you remember, okay, if you remember the self-inductance phenomena, we have taken a variable resistor in series with the battery, and that variable resistor used to vary the resistance, and because of that variation in resistance used to vary the current. आठवतंय का? रेझिस्टन्सचा ॲरो वर खाली व्हायचा आणि मग त्याच्यात करंट व्हॅरी व्हायचा आणि मग नंबर ऑफ फ्लक्स लाईन्स कमी जास्त होत होत्या. आठवतंय का सेल्फ इंडक्टन्स फिनॉमिना?
Yes, ma'am.
Yes, ma'am.
So the same logic we are going to apply over here. Because of the rise in current, or because of the change in current, an EMF is induced across the inductor due to change in flux linkages, and this self-induced EMF across the L, self-induced EMF across L will be given by E is equal to L di by dt. Now there is only one coil, so obviously this induced EMF E will be equal to what? L di by dt. L is what? Self-inductance of this inductor or a coil, and di by dt is what? Di by dt is the rate of change of current. And E is what? E is called as the induced EMF, self-induced EMF across that coil L, okay, or across the inductor L. After the magnetic field is established, the current has reached its maximum value or steady state value. Once the current has reached its maximum value, then further the number of flux lines cannot increase. So whatever the energy which is supplied to the circuit from the battery has utilized to dissipate in the form of heat, means that particular circuit is going to have loss, okay, because now this energy which is going to be supplied by the battery is not going to increase the number of flux lines because current has reached to its maximum value. Okay, suppose this battery has connected a series resistor, and so suppose this is variable resistor. So this variable resistance is having the range, say suppose of from 1 ohm to 5 ohm, 1 ohm to 5 ohm, and battery is of 5 ohm. So when the current is flowing through the circuit is maximum, the resistance is offering minimum value. Okay, so when my resistance is at lower position, minimum position, say it is 1 ohm, so this 5 volt battery with 1 ohm resistance, how much is the current will flow? 5 ampere. 5 volt divided by 1 ohm will give me the current 5 ampere. Okay, and if the resistance is maximum, if the resistance is having a maximum value, say 5 ohm, then at this 5 ohm value, if this 5 volt battery, what will be the current will flow through the circuit? 5 volt divided by 5 ohm, say only 1 ampere. Okay, it means current is going to vary between 5 ampere to 1 ampere. It means 1 ampere is the minimum value and 5 ampere is the maximum. So after 5 ampere, or more than 5 ampere, current cannot flow through the circuit. So 5 ampere is the steady state value or the final value. So when the current has reached to the final value of 5 ampere, and if still battery has connected and battery is giving more energy, okay, more energy, then that energy is not going to increase the current further. So this extra energy is going to dissipate in the form of heat. Okay. So once the steady state has achieved, no additional energy is required to maintain the magnetic field. So that additional energy is going to be dissipate in the form of heat. First phenomenon. Second phenomenon is what? The Lenz law. What is Lenz law? As per the Lenz law, the induced voltage across L opposes the applied voltage. So, because of this opposition, the energy which is supplied by the battery is used to overcome that opposition. Whenever we want to change the current, that L doesn't allow sudden change in current because of the existence of Lenz law. So to overcome that opposition offered by Lenz law, we want to give extra energy to the circuit. So we will supply that energy again the battery. So this supplied energy which is used to overcome that position is stored in terms of magnetic field. So that the energy supplied to the circuit, that is this battery voltage into current into the operating time, because your energy means what? Power into time. Okay. So the energy supplied to the circuit is spent in two ways. First, a part of supplied energy is utilized to meet the I square R losses, which is in the form of a heat, which are unable to recover or which cannot be recovered. And second, the remaining part which is stored in magnetic field is going to maintain the field constant. When the field is going to collapse because of the Lenz law, or when the field is going to collapse due to the decrease in current, that stored energy will maintain the field constant. It will return back to its original position, or it will return back to its original value. So both the ways that energy is going to utilize, that's the supply. One for heat and another one to maintain the field at constant value. Okay. So the power, that's the instantaneous power, which is for this particular circuit. How to find out the power of this circuit? Power will be what? V into I. What is V? V is nothing but the voltage, which is measured in volt. So in this particular circuit, what is the voltage? The voltage is nothing but an induced EMF in coil. Now what is induced EMF in coil? That is E. And that E is equal to what? E is equal to L di by dt. So L di by dt into I is nothing but L I di by dt. Okay, so power is equal to L I di by dt. Now from this power we want to find out the energy. So what will be my energy? Power into time. Okay. So work done is nothing but to overcome the position for short interval of time, say dt, which is stored as magnetic field. Work done is energy. So dW is equal to power into time. So power is Li in bracket di by dt into time dt. So dt will get cancelled. What will be the energy or work done? The work done is Li into di. Now what is di? Di is a change in current. Okay. Now the current is going to change from 0 to maximum value. So the total energy stored in magnetic field from the time the current is 0 to its maximum value. From the current is 0 to its maximum value. Okay. So that the total energy stored in the circuit, to find that total energy stored in the circuit, we are going to find out by integrating the value from 0 to I. By integrating the value from 0 to I. So integration from 0 to I of Li into di is equal to half into Li square. Because integration of I will be what? I square by 2. L is a constant. So L we will take out. So integration of I with respect to di will be I square by 2, and putting the limit I is 0, I'll get I square by 2. So what is the energy stored in magnetic field? Energy stored in magnetic field is E is equal to half Li square, and energy is measured in joule, so the unit is half Li square joule. So this is very important formula. What is the energy stored in magnetic field? Energy stored in magnetic field E is equal to half Li square. Now what is L? L is the self-inductance. So what is the self-inductance? Self-inductance L is equal to N phi upon I. So I'll have the another equation of energy stored E is equal to half. L is nothing but N phi upon I. So I square will cancel with I. So I'll have one I in the numerator. So E is equal to half Ni phi. Half Ni phi. Okay. So this equation no need to remember. What you have to remember? You just remember the first formula. E is equal to half Li square. L you already know. L is what? L is N phi upon I. So when you will put the value of L, N phi upon I, you can simplify the equation. So don't remember the second equation. Okay, only thing is that just to explain the relationship I have solved. Okay, but what is the important formula of energy stored? Energy stored in magnetic field E is equal to half Li square joule. Is that clear to you? Yes?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Now further part, that's the last bit, is energy stored in magnetic field per unit volume. Energy stored in magnetic field per unit volume. Now how to calculate? It's very simple. See. Now E is equal to half Li square, where L is what? N phi upon I. Okay. So by simplifying that, I am getting the value E is equal to half Ni into phi. Now what is Ni? What is Ni? MMF. And what is phi plus? Okay. So can I say E is equal to half MMF into plus? E is equal to half MMF into plus. What is MMF? Ni. Again MMF is equal to what? H into L. What is MMF? H into L. And what is plus phi? Phi is equal to B into A. Okay, why I am replacing this value? Because I want to find out volume. And volume is nothing but what? Area into length. So anyhow, I want to simplify that equation. E is equal to half Li square in terms of length and area. Then how will I convert those particular parameters? I can insert length with the help of MMF, and I can insert area with the help of flux. So Ni term, which is MMF, that I have written in the terms of length, that is H into L, and flux, the term I have written in the form of, or in the terms of area, that is equal to B into N. Okay. So E is equal to MMF into flux, where MMF is H into L and flux is B into A. So energy E is equal to half H into L into B into A. Okay. So now L into A is what? L into A is volume. I want to find out the energy stored in magnetic field per unit volume. Per unit volume. So when I want to find out the energy per unit volume, what I'll do? I'll divide that equation with the term volume. It means I'll divide this particular equation by L into A. If I do it so, where L into A is the volume of magnetic field, which is in meter cube, hence the energy stored per unit volume will be what? The given equation or the above equation divided by L into A. So L and A will get cancelled. What is my energy stored in magnetic field per unit volume? It is only E is equal to half BH. And it is energy stored in magnetic field per unit volume. Per unit volume. So the unit is energy which is stored in joule per unit volume. Volume unit is meter cube. So per meter cube. Joules per meter cube is the unit of energy stored in magnetic field per unit volume. I'll repeat again. Energy stored in magnetic field per unit volume is equal to half BH joules per meter cube. Okay? Clearly understood till this?
Yes, ma'am.
Okay. Now you can simplify all equations by your own. So I'll use the next relationship. B is equal to mu h. I'll put it in the above equation. If If I'll put D is equal
Yes,
to
ma'am.
if I'll use E is equal to mu H, I'll get what? E is equal to mu H square. Second form. Third form, I know that H is equal to what? H is equal to B upon mu. So H square will be what? B square upon mu square. So it will be what? B square divided by this mu is going to cancel with mu square. So what I'll get? B square divided by mu. So that is again the third form. So more simplifications you can do by your own. Okay, but what is the original formula of energy stored per unit volume? Energy stored per unit volume is the first equation, that is E is equal to half BH. Further you can simplify later, okay, by using very different energies. Okay, so if mu is equal to mu 0 into mu r, and if the material is air, we are taking mu r equal to 1. So energy stored in magnetic field, if the inductor is air cooled inductor, then the energy stored in that air cooled inductor is what? Which is half B square divided by mu 0, because mu r value we have taken 1. Why? Because it is air cooled inductor, air cooled coil. So this way you can find out the energy stored in magnetic field per unit volume. Okay, I hope everyone understood it clearly.